So this is going to be a very quick review because of the timing. I just want to show how I'm able to get the location of the field from Agri map, field view, and the Wayback Imagery. So I already have the the DLI of the field, that's southeast 29 8 21 west of 1. So what I did was just inserted it here. I inserted it here, and this brought me to this field. And then below this is the coordinates, which you can see at the bottom left. I copied that coordinate and then went to field view. When I was creating the field, trying to assign name to it, that was what I imputed. The coordinates was what I imputed, and it brought out this image. So that was how I was able to get that from field view. And I did the same thing for Wayback Imagery. I copied the same coordinates and then I searched for it here, and brought me to this point. So Wayback Imagery just showed the vegetation cover over time. Unlike field view, Wayback Imagery covers it's in years. As you can see, 2014, 2016, 2020, 2021, 22, and all of that. So this shows progressive successions as far as vegetation cover of this particular field is concerned. So that is it for the field view here, agri maps, and the way back how I was able to arrive at that. Um, with the help of these PowerPoints, I'm just going to run through some of the points from the rubrics. This is the scouting imagery of the field. This is the vegetation. Uh, this is the look on agri maps. This is the looks on Wayback Imagery. This is the late planting season, which started April 28th. That was when the field was seeded. We don't have any information prior to April 28th as far as this field is concerned. So presumably April 28th was the time that the field was seeded. And we do not expect anything happening in the field at this time. Expect to see low biomass. We expect to see low biomass. We expect to see low biomass at this point. So we expect to see low biomass, but then there's going to be progression as we move into the season, as we're going to see. This is the first sign of emergence, May 28th. We're able to see that because of the changes we're noticing. Yellow, green in most places. The soil is beginning to be receptive, the seed is beginning to sprout, and now the few bioactivities going on in the soil. The peak growth July 30th, and I'm able to ascertain this because of the coloration, dark green. Looking at the information on field view, dark green indicates very high biomass. So the start of dry or die down, 3rd of September, changes in the aerial view from dark green we saw earlier to now yellow and light green. So it's now going down. Show that at the point where we have the peak growth, the soil attained physiological maturity, and now it's dying down, which shows that any moment from now it's going to be harvested. Evidence of harvest was noticed in 30th of September. As we're seeing that the soil or the field is now going back to its original state when it was seeded, when there was little or nothing going on the surface of the field. So I just want to go through the field view quickly, and then so this is scouting, but the focus now is on vegetation. So we have information from April 28th when it was seeded. And as we move into the season, we noticed that there was a progression from low biomass when it was seeded to high biomass, which is the peak period, um, which is a peak period July 30th, and then it's began to change again to light green, yellow, and nine to harvest. Of concern too, it's the amount of precipitation and heat that was available at this time. So if you look at the weather reports, it shows gives us information on this. So the focus for here it's gonna be uh 15th of October, 15th of April rather, April 15th to October 1st. Then we're comparing 15-year average. So as expected, beginning of the season, low accumulated precipitation, but as we move into the season, we notice that there's a rise in precipitation and yeah, because the soil, the snow on the surface of the soil is beginning to melt, and the soil is now receiving more heat and making it conducive for the plants to thrive. And that's what we see too in terms of temperature here. Beginning of the period, we have low 12 degrees Celsius, -3. The highest was 12, the low -3. And that's pretty much it too. It's the same thing to be expected in the 15-year average. But as we move into the season, we're getting a peak, a high of 33 degrees Celsius. And yeah, because the soil is more receptive, the soil is heated, there's lots of high temperature. The soil is accumulating these temperatures, and the plant is responding in that same manner. So I'm just going to quickly highlight information on the Agri map now, though I'm going to still attach this document that summarizes the different soil types, the limitations, explanations of the limitations, and the class of the soil as well. This is just a summary of the information gathered on this particular field which I am working on. But then much of the information is gotten from reconnaissance soil survey data as against detailed soil survey. So if I clicked on it, it brings out all of this information. So the 2WT here shows tells me the soil class. The 2 here is class 2 soil, and this WT is the limitation, which is excess water, and then the topography. So there are just predominantly uh, three soil textural classes as far as this field is concerned. We have the clay loam, silty clay, and the fine sandy loam. If I click on that, uh, three different polygons as far as this field is concerned. So it gives me those information that I need. It tells me this is irrigation or erosion topography, which is summarized in the data in the Word document, which I'm going to be attaching to this assignment. Of significance, of importance to the grower or the farmer is the decision is going to be making, knowing fully well the soil texture classes as well as the limitation associated with these textural classes. So for the clay loam, the soil will support the growth of perennial crops. So the grower will want to look at vines and climbers. He wants to look at growing ground cover shrubs and even some grasses. Whereas for the fine sandy loam, which is in the fine sandy loam, which we have just a minute. Okay, this is clay loam. For clay loam, we've said that the farmer will want to consider the growth of perennial crops, vines and climbers. For fine sandy loam, which is this section of the field, the farmer should be looking at growing root crops that require unobstructed soil. Leafy vegetables too can thrive. Fruits, herbs can also work well in this kind of soil. And then for the third textural class, which is silty clay, it's ideal for growing a variety of plants, such as the herbaceous perennials. Farmers will want to also consider growing roses and shrubs, bulb plants, ferns, and the likes. So, getting an in-depth understanding of the class of soil in each field will give the farmer a better understanding to know the kind of crops that he hopes to plant so as to maximize yield at the end of the day.